Hello, my name is Joel Lamere. I'm an assistant professor at the University of Miami School of Architecture. Today I'll be presenting the past and future of coastal structures, a framework for multifunctional design criteria. This presentation emerges directly from work done as part of University of Miami's ULink initiative, which provides seed funding for teams that are pursuing interdisciplinary research. And interdisciplinary we are. So our team has 2 economists, 2 engineers, 1 marine biologist, 1 architect, 1 librarian, 1 artist, and a host of graduate students from various disciplines. And the whole point of assembling a team like that is to confront complex problems, right? Those with competing criteria, with many stakeholders. An interdisciplinary team is the only way, I'd argue, to take on resiliency issues, particularly along coasts where so many intertwined problems come into contact with one another. And so that line along coasts is where we dove into the problem as a team. Specifically, we focused on coastal structures. Now, we know this is only a piece of the larger resiliency puzzle, but we considered it a critical one. And one where actually it's a very lack of interdisciplinary thinking which has given rise to so many of its problems. The failure of past walls has had something to do with their lack of multifunctionality, we'd say. They're conceived as single-purpose engineering marvels rather than players in larger ecosystems. So our team set up a process revolving around incorporation of our many disciplines, right? One that had as many inputs and design criteria as members of the team, but that also incorporates a feedback loop of assessment and analysis, including economic analysis. So our team started simply by looking at what is around us in South Florida. We traveled to many sites that exemplify a range of strategies for coastal protection. We saw, for instance, historic and contemporary seawalls. We saw natural and green gray systems, as well as various remediation efforts, which we documented, then analyzed in terms of management processes, restoration efforts, protection strategies. All this helped gain a better understanding and common language around coastal structures, of course, but more importantly, helped us organize the narrow set of design criteria for the wall types currently in use. And this in turn led directly to a provisional framework for scoring seawalls in terms of these structures or criteria. And that was the subject of our first published paper, Multifunctional Performance of Coastal Structures Based on South Florida Coastal Environments. In the paper, we gather and organize the documentation of each of these sites. There were 8 of them in all, including site-specific variables. And then we assess the walls along several axes, leading to numeric scores that we can then compile. In keeping with the setup for our whole team, we obviously needed to understand these structures in terms of multiple functions. The first of these layers of functionality, maybe the most obvious one, is the engineering functionality. This is pretty easy to understand. We need to know how well these structures are doing their basic job of protecting the shore from the influx of water due to tides and storm surge, how well it is retaining the land and so on. So the assessment criteria we used to score each wall included some obvious measures, width, height, but we also wanted to include an aspect of affordability in this, insofar as the engineering design has a say in the cost of the structures. And this is really important to capture when you're analyzing coastal structures. The second layer of functionality we are calling the ecological functionality, which is to say, how the structure positively or negatively contributes to the overall ecosystem health. Obviously, there are several metrics we could have used for that as well, including rugosity, which is a measure of its textural depth, which is key for marine growth on that surface. We also settled on figuring out how well the wall helps in the management of stormwater, which comes to all kinds of potential ecological impacts. And we even looked at diversity of nearby plant species as one assessment criteria. The final layer of this assessment was in terms of stakeholder functionality, which is to say the value that these structures have to residents or other people who are directly in the vicinity and affected by it. The criteria here could be really, really broad, but we've wanted to focus on questions of its public use, the quality of use that it allows, which according to a survey we conducted was of critical importance to users and property owners. And here we even looked at like the diversity of bird species nearby. And this is part of a metric of desirability, let's say. So the paper compiles all of those assessments, scores them, and creates a composite total for each structure. We also included narrative descriptions to paint a full picture of what we observed, and we conclude the paper with a rigorous ranking based on the composite score of these existing structures, which also helps us sort in very broad terms, which coastal strategies are more effectively addressing multifunctional demands. And that's the real accomplishment of the paper, right? This framework for multifunctional assessment. And that's why it's the key foundation from which a few other studies are naturally springing for us, right? This framework allows us first to assess the multifunctional performance of other seawalls. That's pretty clear. But also, very importantly, it works as a tool in the design and planning of new coastal interventions. This work is not purely for retrospective purposes, in other words, but obviously meant to help us consider how to proceed in the future. So that's what we're doing. One of our studies, ongoing studies, is a comprehensive mapping and assessment of the existing structures for all of Biscayne Bay. This involves a lot of spatial modeling, creating GIS polygons for each segment of the coast, and including attributes that include the type of coastal structure at each location, its condition, its jurisdiction, and of course the various functionality assessments based on our framework. We've also been using the assessment framework in preliminary ways to address site-specific concerns. It should, as we already said, be able to inflict how we design for interventions. So we were working with North Bay Village as a community partner to conduct research related to their needs at several sites of their choosing. For those that don't know, North Bay Village is a set of islands nestled in Biscayne Bay between Miami Beach and Miami proper. And the whole island is hovering really just a few feet above the current high tide and is already grappling with many of these issues associated with sea level rise for that reason. So really, it's an urgent need for them to start to address these questions. One of the things we are doing for them is to simply look at several sites they have chosen for potential redevelopment and ask questions about how our observations and this multifunctional assessment framework might guide the design of coastal structures at the edges of those proposed or potential developments. So, rather than thinking of a seawall as a kind of pure barrier or a single line, we really want to consider it as an important piece of a larger territory, one that interacts in all of these important ways with the local ecosystem. So in our proposal, we've assembled many of the components of successful strategies we've seen elsewhere in hopes of producing a zone at the edge of the site. This is not just ecologically forward thinking, which it definitely has to be, but is also responsive to stakeholder and engineering interests in inventive ways. Each design component really is meant to serve multiple functions in that way. So for instance, the boardwalk, which serves to obviously augment views and increase water access, both of which are really highly valued by residents. That boardwalk also acts as structure and protection for a series of floating wetlands that help sequester nutrients. The seawall, for instance, is designed obviously as a protection, but also designed to promote marine ecosystem development. And importantly, there's a buffer zone between protective seawalls. So we saw that if you can use depth along that coastal edge, you will be much more protected in many ways. But the key to using that correctly is to also program that zone, right? So allowing people to use it for play or activities or retail. In that way, the space isn't lost, so to speak, in terms of the stakeholder value. And that brings us really to the last part of this presentation. The design work makes it very clear that there is a missing step, right? That there should be a design guide that allows for comparison about the many options available for coastal structures. We identified this as a major gap in the process for designers and engineers who are tasked with taking on these complex problems. In a way that there's this litany of possibilities, but no way to compare and contrast from one to the other in a kind of a standardized way, which would be helpful as a designer. So in response to this particular need, we began to create something like a design guide, a catalog of these past and future coastal structures. So in order to be functional in this gap, in order for it to fulfill this need that we've identified, the guide needs to catalog coastal structures of many, many kinds, right? So conventional hard infrastructure, green-gray strategies, natural barriers, and so forth, but also the range from historical and existing structures to contemporary and emerging strategies that rely on newer technologies. For each of these entries, it has to provide a useful summary of its overall value, right? So it includes a narrative description for those things that can't be reduced too easily, but also a data-driven assessment, right? Including our scoring for multifunctional performance. We basically need to be able to compare all of these coastal structures across the various criteria identified in our rubric. We really need to put them side by side to rank them in these terms. And then we've included a few other clear metrics, including use case, carbon footprint, construction costs. And I'll point out here that we've also included a line for availability, where for emerging technologies, we can indicate how many years away the technology seems to be. This is, of course, in some cases less certain than others, but we feel strongly that the kind of longer-term thinking that is necessary for addressing issues of resilience and climate change, that longer-term thinking only works if we can see into the future a bit, right? We have to know what is on the horizon to know how we should act today. So the catalog is ordered somewhat chronologically, beginning with the historical structure that you see on the left. That was one that we saw. And then leading into related contemporary structures and developments like the one on the right. In this case, a University of Miami team, that includes 2 of our ULink team members actually, developed a modified wall that uses GFRP, which stands for glass fiber reinforced polymers, instead of steel for rebar and tiebacks. The advantage here is pretty obvious, right? Where steel corrosion is a massive problem and the cause of many seawall failures. Critically, this design was included as one of the approved seawall design options in recent changes to the North Bay Village zoning code, making it an instance where research outcomes were directly merged with community needs through a collaborative process. And because it is an established innovation, there's good reason to include it in our catalog among other available strategies. And if we think a bit further out chronologically, we find some innovations that are currently under development, right? Not too far away from being functional. For instance, this seawall cap for retrofit and repair purposes. There's a massive number of existing seawalls that are mildly damaged or simply too low, but maybe aren't in such bad shape that they need to be completely replaced or torn down and replaced. Because that's the case, many people have been looking at the possibility of producing custom caps that add height to deal with sea level rise, cover flaws, and even potentially shore up the structure itself. And in keeping with the multifunctional theme running throughout this whole presentation, these caps might add other functions in this retrofitting process, like filtration systems for dealing with runoff, or planters for sequestering nutrients, or textures to encourage marine growth through rugosity, and so on. More or less as optional add-ins to the cap itself. The development of these custom caps is already underway and maybe just a couple years out and are listed as such in the catalog. But there are some new technologies that are right on the horizon that promise to fundamentally alter some of these strategies. So for example, in a few years, 3D printing concrete seawall caps may be possible. We already see 3D printing of concrete in domestic applications. And this promises to be cheaper and more effective. So as a designer, it is useful to have a kind of time horizon for this technology, right? Maybe it's better not to dive into using the previous caps that we showed, which would require a ton of measuring, custom formwork for every single different seawall, offsite casting and shipping to the site, when you could instead scan a wall to get a digital model of the exact existing geometry, then use a parametric process to define the layering patterns, and then print directly in situ. If you have a sense of how varied and irregular that so many seawalls are, especially if they have been out there for a while, you can probably guess the kind of paradigm shift that we are talking about here. And eventually this 3D printing process will be useful for even much more robust purposes. You will be able to engage both water and structural functions directly. So rather than just a cap, you will be able to produce full walls in this way. So we should admit, right, that some of this is in a very fundamental research phase, and so it has to be a guess about how soon down the line this may be possible, right? Like we're not going to know that exactly. We have listed 5 to 10 years in our chart here based on the rate we've seen other concrete 3D printing applications evolve, but who knows exactly? That's why we consider this a living document that will need continual updating to reflect evolving knowledge. So as a team, we've been looking at what those walls might look like, these 3D printed seawalls. Much of my own research is in digital fabrication, emerging means of construction, and the relationship between form and structure. So this has a pretty direct relationship to that. I've come up with what I'm calling the pleat, just to exemplify one such possibility of a wall, right? So the premise behind this project is that, again, it's 3D printed in situ, meaning that it doesn't require any formwork and minimal excavation and shoring. The profile itself reaches a linear edge at the top to maintain the definition of the property line, but gets thickened or deepened at the base for obvious structural reasons, to resist overturn and the like. And it wouldn't be a 3D printed wall if it didn't have some sort of adaptivity or adaptation built into it. So the idea here is that, of course, adaptive layering would allow for the many irregular kinds of site conditions that are experienced at shorelines. So you'll notice that there's real optimism in this catalog. The further we get out chronologically, the more we see designs that are truly multifunctional and therefore score higher in our assessment framework. So long as the technology continues to develop as it already has, we can hope to arrive at schemes like the one I've designed here eventually, right? Within a single wall section, this one is trying to take on 3 major tasks: filtration, structure, and the production of a well-calibrated marine habitat. So this concrete sponge is a continuous shell, which is an extremely efficient structural type using very little material means to maximal ends. It's a single print that performs varied functions, deploying material resources sparsely but effectively. I want to conclude by reiterating that this catalog is a work in progress and will always be a work in progress. By definition, it needs to be a living document. But our hope is to get it up to at least some distributable quality level soon, though, as is the case with some of the wall designs we've already shown here, the timeline for that distribution would be a bit speculative at this point. Thanks, and I look forward to answering any questions you may have during the Q&A, where I will be joined by my colleague, Esber and Andiroglu. Thank you very much.
Hello, my name is Yanel the Angel. I'm an architect with Perkins Will and Resiliency.
Hi, my name is Danniely Staback, visiting lecturer at the University of Illinois and the Rhode Island School of Design, and a collaborator of Resiliency.
Hello, I'm Manuel Fontan. I'm a licensed engineer, a Resiliency collaborator, and I lead analytics efforts for WSP Sustainable Design Practice.
Hello, my name is Jesabel Rivera. I am Executive Director of the Voluntariado de Ingenieros.
Hi everyone, my name is José Sanchez. I am an engineer at Chief Structural Engineers and co-founder of the Voluntariados of Engineers and Professionals of Puerto Rico.
Hi, I'm Ruth Super. I'm a lecturer at the Boston Architectural College and a designer.
Thank you. So with that, we are going to share our presentation. After the devastation of the magnitude 5.8 and 6.4 earthquakes took place on January 6th and 7th of 2020 in the southern part of Puerto Rico, two nonprofit organizations, Resiliency Puerto Rico and Voluntariado de Ingenieros, and one academic institution, Boston Architectural College, and various private industry experts joined efforts to provide pro bono services for one of the most affected coastal municipalities, Gúanica. And while the municipality had an emergency plan, it lacked a shelter program to serve their diverse, vulnerable population. This project is about the co-creation of 3 year-round community centers that transform in shelters during an emergency.
The product we will share is thanks to a dedicated team of volunteers. Highlighted in red is the group presenting today. As mentioned before, my name is Jesabel Rivera. I'm the co-founder and executive director of Voluntariado de Ingenieros. We are a 501c3 nonprofit organization registered in Puerto Rico, dedicated to facilitate disaster mitigation, recovery of low-income families and communities by engaging volunteers and professionals.
I am Yanel the Angel, as I mentioned, principal at Perkins Will and co-founder of Resiliency Puerto Rico, which formed right after Hurricanes Irma and Maria. We are a global alliance providing resilient design and planning to communities of every scale. And here is our website, which you can visit to learn more about our projects. I like to point out an important resource that we use and we have led with many collaborators that you see here in the screen. It has guided our work with communities seeking to create resilient community centers. The guide really answers the question, what is a resilient center and what are the attributes that it should possess? It is organized in 4 parts, beginning with organizational capacity, operations, and physical assets. And my personal favorite is chapter 4, that covers a diversity of exemplary case studies.
The objectives of this project revolve around co-creation, and to do that, we had to understand the context first, to design an inclusive space and develop a conceptual program of spaces to support the community before, during, and after the emergency. In working with the municipality, they offered these 3 locations. Each site is within a neighborhood and offers development areas ranging in capacity. In the larger picture of the municipality limits, they are located as shown and can shelter the target vulnerable population desired.
In the past 3+ years, the island has experienced severe hurricanes, a major earthquake, even a meteorite, which luckily landed in the Atlantic Ocean, and of course, the global pandemic. Gúanica is susceptible to flooding, landslides, structure collapse. It has vulnerabilities such as formal and informal settlement damages and collapse, population displacement due to flooding, compromised health, safety, wellness, communication, and food supply disruption. You can see here the severity of the earthquake damage in informal construction. And as we consider inclusive design for a vulnerable population, we ask some critical questions to enable discussion. Who is this population seeking shelter? What do they bring with them? What do they fear? What are the health issues they might have? And how do they navigate the shelter once they are there? We created an adjacency diagram to guide the space planning. And as you can see, there are three kinds of spaces, really the large assembly space in yellow and some public support spaces and services, back of the house kinds of services as well. From the presence we studied, this Japanese system really stood out for speed of assembly, the affordability, the flexibility, and the privacy it provides. It's a simple module cardboard system with curtains for privacy. It is very close to what we had in mind, and you will be seeing that coming up.
Hello again. I'm Danniely, visiting lecturer at the University of Illinois in the Rhode Island School of Design and a collaborator with Resiliency. In our proposal, we achieved a sizable capacity for the 3 shelters and for each emergency scenario, hurricane and earthquake. Since the municipality may apply for FEMA funding, we also tallied the occupant density for the FEMA Community Shelter Grant. The project team created a holistic, replicable, and scalable shelter framework composed of key elements. The shelters function as independent community centers with programs that serve the community, including 1, 2, or 3 basketball courts for multi-purpose activities. The centers transform into shelters during emergencies. To further illustrate the concept, we developed the 2 basketball court version. This is the overall building massing and adjacency. You can identify the different resilient design components such as water cisterns, PV panels, natural light, community garden area, and outdoor programs. This is what the center looks like during regular times. A public entrance leads into the smaller volume, which houses the year-round services. The main hallway connects to the larger volume, which has multiple entrances. These circulation paths connect to the exterior assets mentioned before. For year-round use, we integrated inclusive spaces for all, including a mother's room, a quiet room for people with sensory sensitivity, and a fully accessible adult changing room that doubles as a gender-inclusive bathroom. During a hurricane scenario, before and during the event, the main services are contained within the building, as well as the shelter space. The colorful volumes represent various sizes of temporary shelter units. Temporary toilets, sinks, and showers are shown in purple and blue. After the hurricane or during an earthquake, additional services can take place on outdoor temporary tents to increase the occupant density. I want to know that our team incorporated COVID-19 provisions, anticipating the possibility of a combined natural disaster and pandemic event.
I am José Sanchez, Senior Engineer at Tipping Structural Engineers and co-founder of Voluntariado of Engineers and Professionals of Puerto Rico. This axonometric view depicts the structural system shelter. The structure consists of a concrete structure in the front, where the entrance and offices are located, and in the back structure was designed as a structural steel to provide large open areas at the main shelter area. The shelter was designed per the Puerto Rico Building Code 2018 version and considered the hazard of the island. Hurricane wind load forces and earthquake demands were considered for the area of Gúanica. This shelter was designed to resist winds up to 182 miles per hour and seismic demands up to 1 G of force. To put this wind velocity in perspective, is 3 times the velocity that you are allowed to travel by car on a highway. These speeds are the result of the revisions done to the code after Hurricane Maria hit the island of Puerto Rico in 2017. Two structural options were considered during the design phase to provide the flexibility and strength for the building code, shown in those 2 images.
Hello again, I'm Manuel, licensed engineer, resiliency collaborator, and also the analytics lead for WSP's Build Ecology Sustainable Design Practice. This section illustrates different resilience strategies, including passive survivability through harvesting natural light, natural ventilation, and daylighting. There are also water cisterns and renewable energy to allow the center to survive for a few days independent of the municipal services. Before estimating water and energy loads for all 3 scenarios, we first determine occupancy during normal operations and sheltering events that will drive resource consumption. We follow ASHRAE 62.1 occupancy rates and supplemented our findings with FEMA's community safe room guidelines during emergency response. Preliminary loads follow USGBC's lead design guidelines for indoor flushing and flow fixtures, as well as water use. A supplemental water balance calculator was included to estimate water storage tank to satisfy a 3-day blackout demand and rainwater capture potential for each scenario. On the energy side, preliminary loads follow ASHRAE 90.1 and ASHRAE fundamental handbooks guidelines to determine schedules, lighting, and equipment power densities, but also human heat generation to estimate cooling load during sheltering events and normal operations. Lastly, using Ensenada's Gúanica weather file and PV Watch software, it was determined that 20% of roof space for dedicated solar PV can provide net zero operation during business as usual and offset up to 88% of energy demand during emergency operation.
Hi, as I mentioned before, I'm Ruth Super, a professor at the Boston Architectural College. Critical to the students' work was the integration of next generation talent through a real-life collaboration. 2 Masters in Design for Human Health students participated in this studio that focuses on the ADA and inclusive design. Ana Rios Sabater, a Puerto Rican junior architect, developed the shelter modules for the diverse population and a wayfinding concept using adjacencies, colors, signage, and lighting. Ryan Downs, a student and registered architect with prior FEMA experience, developed a site logistic plan for emergency operations and an exterior shower concept exploring levels of privacy for an inclusive design. I developed the operational policy based on my expertise and prior experience as an architectural designer for the Institute for Human-Centered Design, an international inclusive design nonprofit. With IHCD, I co-created an ADA and inclusive emergency community shelter checklist and policy program. It incorporated ADA, FEMA, and inclusive design requirements and recommendations.
We learned that remote collaboration is a powerful way to connect professionals to contribute expertise. We highly recommend engaging academic partners. The BAC brought a different perspective, depth, and genuine investment in nourishing the next generation.
We also learned that a facilitating municipality is critical, but needs to be paired with community-based organization involvement. We recognize there are many obstacles, inequities, and unfairness in providing direct relief to communities, but we are determined to help overcome them. We want to thank the former mayor of Gúanica, Santos Seda at the time, Reverend Benjamin Toro from Bet El Torre Fuerte Church, and Juan Carlos Alvarez, FEMA Municipal Supervisor, whose collaboration was critical to the.
Good morning. My name is Laurie Schoeman. I'm the National Director for Enterprise Community Partners, Resiliency and Disaster Recovery Work.
Hi, I'm Ricardo Alvarez Diaz. I am the ex-president of the Builders Association. I'm currently the chair of the ULI chapter in the island of Puerto Rico, and also the co-founder of Alvarez Diaz and Villalon, a local architecture and interior design firm.
We are so happy to be with you today. We're going to spend the next 15 minutes telling you about our Keep Safe effort that started in Puerto Rico and has moved to the Miami and South Florida region.
Well, I'll tell you something about this. Many of you know already, but Puerto Rico was hit by two devastating hurricanes in September 2017, and you know, it actually is Hurricane Maria itself. There's two. It's Hurricane Maria and Hurricane Irma. And Hurricane Maria is one of the most powerful hurricanes to hit the U.S. And U.S. territories in the last 100 years. When that happened, Laurie and the Enterprise Communities team quickly wanted to find a way to help the people of Puerto Rico, and we gathered maybe a month and a half after the hurricane in New York, Laurie and myself, and we basically sat down and what could be the best long-term mechanism to actually help the people of the island of Puerto Rico. Many people showed up and many people helped short-term and mid-term, but you know, the intent was to come up with a solution that would be useful for years to come. And that's when we got together with a lot of people. So Laurie could say it in more detail, but we realized that if we created a document that could not only help professionals, but also help the people in neighborhoods to better understand the impact of a situation like that, and how to better prepare themselves in case of another hurricane or another national disaster, it would be it would be the best investment we could do.
So we pulled together about 200 leaders from across Puerto Rico in planning, design, community leadership, and decided what are the strategies for safe and resilient housing we wanted to focus on. And what was once thought of as a brochure, which quickly became a 500-page book in Spanish and in English. And one of the things that we were very cognizant of is the Hurricane Maria was just one incident out of generations of impacts that Puerto Rico has faced and will face going forward. We're in a new normal reality where so many communities are literally on the tipping point of whether or not they are going to be able to last through intense flooding conditions, intense storms and earthquakes that are projected to fall upon so many communities. So what we're trying to understand in our housing resiliency efforts, how do we reframe housing so that it will withstand and adapt to the future changing conditions, many of which we're aware of, many of which will strike us as unusual and will compound and exponentially aggravate existing challenges and deficiencies in infrastructure and in housing.
And housing is the first step, because housing is the biggest investment people will do in their lifetime. So, and then this quickly moved from housing to understanding community. And I think that Laurie will talk a little bit more about what are the impacts that we focused on. And we, again, in the process quickly realized that this was not only something that happens in the islands, it's something that's happening all over the US. So.
The loss of affordable housing, as Ricardo points out, has devastated so many communities, especially communities that depend on affordable housing to maintain tourism, economy, the workforce. It strikes me when I work around the country how many communities that have been impacted by fires or hurricanes lose workforce, and then who is there to rebuild?
Correct.
So this is a big challenge, and for us, making sure our housing is solidly resilient is our challenge of a lifetime.
And that's why this book was developed, because it's not only trying to put things back like they were before one of those national disasters hit, it's understanding how quickly you can get back in place. That's why the word resilient is so important. Resilient housing. How can we get back, and how quickly we can get back? And the intent of the book was basically beginning with housing and understanding the impacts and what people can do in order to create resilient housing within their communities.
And it basically, the book takes us through the sequence of how you construct a building, how you design a house from the very beginning, where you're trying to understand what your hazards are, what your conditions are, what your site is, how to deal with the bones of your building, moving through the interior components, your mechanical systems, your water systems, the skin on your building. We understand and we promote housing as an integrated unit of dynamic systems that work together to create what we know as our home. And we also understand that housing faces extreme risk, not just currently, but in the future. We really are moving into a very volatile period where there's a lot of changing dynamics that are occurring between the warming seas, the heating earth, and how that will impact the weather patterns that will shape our lives. And we explain this in the book very clearly.
And adding to what Laurie said, we also went into detail about site selection, because I think that sometimes when we focus too much on housing itself, we forget the location of the housing, and we forget the impact that location might have within the community. Your property might not be damaged directly by a natural disaster, but the problem is that because of its location, you are now stranded in the middle of nowhere. So location site is hugely important, and how we can educate people of understanding the challenges in action, or the importance of choosing the right location.
And then, of course, the question upon us right now is, how will we pay for all of this work? And one of the earlier conversations Ricardo and I had when we began this effort was that there was a sum of funding coming into Puerto Rico at the time through HUD CDBGDR program, and then later MIT program, to fund resilient housing, to build back better. And because we were aware of this funding coming forward, we want to make sure all federal dollars that come into communities will positively affect communities and help to support housing that will be resilient for decades, because this is a once in a lifetime investment of federal dollars. And there are federal funds coming into our communities.
Correct, and this is something we go at the end of also in the book, so people understand the funding. The different types of fundings are going to be available. It's not only the traditional type of funding that we know, which is FEMA. There's CDBGDR, like Laurie said. There's a mitigation CDBGDR funding. Now we also have added elements with the American Jobs Plan by President Biden and the Biden administration. So if you start seeing things in a holistic way, instead of only focusing in little different areas, we can better utilize those funds to create sustainable economic development, instead of actually just pouring money into bad money. Every time you fix something in the wrong location, every time you fix or put money and just get the properties to the same level they used to be before, you're missing the bigger picture of understanding what the location matters, and what is the economic impact of reinvesting in the same area. So looking at all these mechanisms allows the homeowner to understand what would be the best solution for themselves and also for their communities.
And further to that, we realized that the house in itself is connected intrinsically to the infrastructure in the community, that the house is infrastructure. It is part of the grid. It is the recipient of electricity from the grid, and it can also be a generative unit and provide electricity back to the grid. So there's a relationship we try to investigate in the book between housing and our standing and standard infrastructure in general. And as infrastructure funding gets deployed to communities, to Puerto Rico, we would like to make sure that it is tying together with the sustainability of homes, and that there's an interconnected, intersectional grid.
Well, and the point of sustainability is key, because you can rebuild a home and then just put an air conditioning again. But what if you start taking in account sustainable and passive design mechanisms to actually allow you to survive during those challenging times and make it at the same time sustainable, and then partly as a separate topic in terms of resiliency. We can talk about one of those projects that that if you follow the code and you follow the rules, you're going to be able to actually minimize the damage. We in 2016 began the construction of the first mixed income affordable housing project in the island. And when we designed it, which is called Renaissance Square, when we designed it, the location was key. We identified a location that was an urban location. In case of a situation, people could still walk around instead of actually having to get into a vehicle to get to for their needs. The sustainable mechanisms and methods using photovoltaics and so forth, and resiliency also with power plants. But the thing that's interesting here is that this structure was not affected in any way because it was built by code. It was built following the requirements, and we went a step beyond. We went a step beyond understanding actually elements that we go through each one of those chapters in the book. And we later on received federal funds to make sure that we can make the product resilient also. So in a way, Renaissance Square, and we love the name because it's a Renaissance, right? It became the iconic affordable housing project that is actually making sure that communities are not relocated after a hurricane, because the strong need communities stay together, and you start to create neighborhoods by following the different steps that we go through in detail in each one of the chapters in the book. So you can focus on your individual property, or you can focus many of the elements that we use in the chapters as a design mechanism or as a holistic view of how to better design multifamily projects too. So this is an example of, if you go through some of the elements that we include in the book, you're going to be successful, and you're going to definitely minimize the amount of damage you'll receive after hurricanes. And you know, one thing we learned in this process, Laurie and I, is that Puerto Rico, it's not unique. It's in a way, it's a microcosm of what's happening already in the mainland, what's happening in Florida, what's happening in Texas, what's happening in California. So that's why we took this, you know, original idea of keep safe Puerto Rico, and then maybe moved it, and then actually move it to how we can apply the same idea in different areas in the US. And from there, we moved to what we now call Keep Safe Miami.
And Keep Safe Miami is an effort to support the affordable multifamily housing stock in Miami, now Miami Beach and Miami-Dade, to be more resilient as Miamians confront a future of extreme heat, extreme storms and precipitation, and wind. And so we at Enterprise partnered up with the city of Miami to create a program that would help owners of affordable housing understand their risks from the inside and out. And we provide owners with a do-it-yourself assessment of your building. And you will create the assessment and move through the building. And then at the end of your walkthrough, you get a report. And that report spells out all of the strategies you can do in your building to increase its resiliency and adaptation to future events, current and future events. The city of Miami has generously put together a fund called the Keep Safe Fund to support up to $100,000 per building strategies that increase the resiliency of the affordable housing facility. And what we're really excited about is that this is a partnership bringing together the city, bringing together CDBGDR funds, bringing together innovation, bringing together the Keep Safe community to create a program that will really, we hope, be a model for other cities and communities around the country.
You know, and what started as a very short conversation in New York City, a couple months after Hurricane Maria in Puerto Rico, has now become a standard that enterprise communities is actually moving slowly to make sure that we can educate people around the country. And in a way, I'll finish with this. You know, this is something we owe for every single person that lost their lives, not only in Puerto Rico, but around the country every time a national disaster hits. And being Puerto Rican, I can tell you that this is important for me specifically. Over 3,000 people died, more people than 9/11, and we have the responsibility to make sure that their lives did not disappear in vain. So thank you, Laurie. And I know that the Keep Safe Miami is that legacy that we started in Puerto Rico.
I could not be more honored to work with someone, such a brilliant architect and leader as Ricardo, and it has been a life's honor to do this work. And I couldn't have said it better than Ricardo. We are dedicated to the memories of everyone across the world that is suffering from climate change that's upending their homes and communities. Thank you so much, and we look forward to speaking with you later today.
Thank you.
Hi, everyone. My name is Jacqueline Touzet. Thank you for attending this talk on high performance building design for resiliency in subtropical coastal regions. I would like to share with you some of what is happening in our industry and our profession with regard to designing for climate change in our region, and specifically designing for increased water, heat, and stronger winds. Materials that we're seeing that perform for our new needs, and also just touch upon planning for a positive energy future. What could that look like for a region in one of our projects that we're working on? We're aware that this is a very complex topic, so we don't have much time. So really, it's just a sort of brief overview of what solutions could look like. Our studio has been working in this region for several decades. My husband and I are founding principals of Touzet Studio. We started after many years of working as vice presidents at Arquitectonica, where we did work in Singapore and Hong Kong in similar type of climates, but different region, different culture. And we started this studio 17 years ago to focus really on this region. Something that we're very passionate and fond of, because both of us are Cuban. We're born in Cuba, but we've been here, as I said, practicing in this region for all of our professional lives, with some exceptions in Europe and Asia. What we want to talk to you about today, what I want to talk to you about, is sometimes people ask us, well, why would you practice in Miami? And our response is, well, you know, show us a place on the globe that isn't going to be affected by climate change. And this is where we're from, and we're very proud of being from here. And granted, our challenges are not small; they're quite intense. But I think everyone can agree that we are all facing quite a few challenges. This is from the New York Times, saying every country has its own climate risk. And this region actually, I think, is probably expert in designing already for some of these risks. One of them, of course, is wind. I came of age and graduated in 1992, the year of Hurricane Andrew. And that was such an incredibly powerful learning experience for me. And it really has shaped the way I view the importance of design, architecture, and codes, frankly, in saving lives and in preparing a region. What we learned was that this type of experience, and we have centuries of this type of experience if you're from this region. Actually, if you do it right, you can learn to be better prepared for the next one, and you can become expert in a way at community resilience from understanding what happened. And what was important about Hurricane Andrew is that we changed our code as a result of what happened. We understood that certain areas got much more damage than others. And I think what was really powerful about that was that architects set about understanding, well, what can we do? Okay, what can we change in our code to make us safer the next time? And I think if you look at what we did, some of those things were very simple and inexpensive and cost pennies or cost $1 to put a strap on a rafter, change the type of the fasteners, the spacing, enforce the code to make sure that people were not cutting corners. And as a result, we became the model for the region, I think, on how to build stronger, more resilient, because if you don't get as much damage and you can come back faster, then by definition, that is more resilient. So some of those lessons don't need to be expensive, and obviously some of them are. And if we had sat there back then in 1992 and really thought about how much money it was going to cost to put impact resistant glazing on all of our skyscrapers and our new buildings, I think we would have all been very daunted by that. But in fact, we did it. And as a result, we are in a much better place than we would have been and we are much more viable as a community, and we continue to grow because of that investment that we made then. And that hasn't stopped. So these are the maps that we were looking at then. You can see it's 150, 100, and then it grew to 180 and 210. And now, wow, we are really at 200. So the maps are keeping, at least the wind maps are keeping up with the science. And it's telling us that we can't relax our guard, that storms are getting more intense, and we have to design with pretty robust structure to really address that. And I will say that I think our region is a leader in that, and I'm very proud of that. And that's what I'm hoping to see us do when it comes to resiliency in other areas, whether it's water or being more sustainable so that we can minimize the overall damage that's coming. But we know the water is not an easy one, right? And I think I'm not going to really get into it too much because I'm sure it's being discussed in this conference at depth, but water is coming from everywhere, basically. And how do you design for that? And what does that look like? That's one of the things that I really want to show you, what it can look like, and what cities are asking for and what we're doing. We know that there's a lot of lessons from early builders, and I will say this as a proud Caribeña, and we are experts since the earliest Tainos built on this land to the Cuban Americans to the Bahamians. There's so many builders that came to South Florida. The Bahamian builders were called the Wayfinders, who built much of what we know as a Coconut Grove. And all of those lessons are important and valid, and we learn from them. This was an early house that we did a dozen years ago in the Bahamas, taking all of those lessons, the shady porches, the hot air rising, the cross ventilation, the cisterns. These are things that are centuries old and can be perfected and can be really done beautifully and should be, but we need to do more. It's not enough anymore. When we look at the Bahamas and doing work there, we still are doing it. You can see that even this building has the cisterns, it has the cross ventilation. Now, though, we're talking about elevating all the MEP structures, and how to do that, because people would have put it on a slab on grade before. Well, that's not smart to do anymore. And every house we design, whether it's in the Caribbean or in Florida, we are elevating and creating a structure really for all of these mechanical systems. And we're designing as if we're in a flood zone no matter where we are, because the fact of the matter is we are in a flood zone. And here is another lesson from the early modernists, which we love, the tropical modernism of Cuba, Brazil, Mexico, South America, and also, of course, the Sarasota School. We learned that big roofs are like hats that shade us and protect us from the sun. We learned that elevation captures the breezes, and we learned that it gets us away from the insects. So these are, again, early lessons that are still very relevant that we still use. This is a 2008 building. This was for the founder of Alienware. He was interested in a high performance building. He wanted a house that was above and beyond the code. So this was designed beyond code, which now probably meets code for the structure. And you can see it was designed where the water could rush in under the ground. It was designed with shady, everything was under shade so that the glass was protected. And it was designed with local materials so that it fit into its context. It has a lot of keystone, some material that we love and is regional, and we believe in using regional materials. But what started to become different for us in this project was the idea of a high performance roof that did all of those things, the cistern, the cross ventilation, et cetera. But it also did capture, it used the roof to capture energy and sun. And that was the first solar roof we did. That was 12 years ago. And we've been hooked on solar ever since. And we want to do solar everywhere because we believe in the sunshine state, and all of our regions should be solar at this scale, at the single family scale. And also we'll show you one that is at the city scale as an urban microgrid. We believe this is the future. Every roof should be a high performance roof. If it's not capturing energy, it's directing rainwater into cisterns, or we've done a lot of green roofs and vegetated roofs, and now we're even looking at farming on roofs. So the roof has a big role to play in the future of our region. This is another example of the materials. It is a combination of local materials and also high-tech materials. Like this is it's not wood, it's rice husks to look like wood, so it requires less maintenance, and it uses recycled materials. And again, lifting up those mechanical equipment. And then the idea of shading for the sun, again, nothing new in our region. We've been doing sun shading from the tropical blinding sun since we learned it from the Moors, and it came down to Cuba, and it came down to other tropical areas in the Caribbean. It's nothing new, but we have taken it to a different level with more resilient materials, in the sense that these are materials that can withstand, again, the structural requirements, and also what very interestingly enough, have some microbial and flood resistant qualities that we're very interested in. This project is designed for Nike. It's a global design technology company, very interested in performance. They told us we're a high performance client, and we said, great, then let's design your building the way you design your shoes. Let's look at the sun. Let's look at where we need to shade for the sun, because they wanted to do a glass box. And we said, no, that really is where you are, the orientation, you're going to be in a very uncomfortable position. So and then they said, well, we want to do this green, but we'd like to do it in a dark metal, which is what we've done in Portland and we've done in Seattle. And we said, that is not a tropical material. That is not a Miami material. And so we convinced them to take that idea, and we transformed it into something that could be cast into a lightweight concrete brise-soleil. And that's that ductile material that I mentioned. And the advantages were that it was non-porous, it was lighter, it could be prefabricated. It was a great flood resistant material as far as we're concerned, and we're fascinated by it. And so we experimented with it. This is one of two projects we've used this material in. And what we love about it is that it can be perforated, it can be cast, you can 3D print the mold and then make the facade out of it. So it was a really interesting process that I don't have time to get into, but it is much lighter than regular concrete, and the pores are much tighter. So we like that about it. The disadvantage that we found, at least in some of the applications, is to design for our wind loads, the amount of steel was just a lot. And we thought that was expensive. And still, of course, concrete has a relatively high carbon footprint. And we are very much, all of us in this region, a concrete oriented building construction. So we do believe that there is a real importance in solving for and working with concrete. This is what we were able to do, which is to perforate that skin and create a lantern at night that was beautiful. And so from an architectural standpoint, we loved it, but we still have a ways to go. And the technology is really quite interesting right now, because we're just like this doesn't rely on metal for reinforcement. It had fiber reinforcement. The next generation of concrete, it's also glass fiber reinforcement, which is really interesting, where they get rid of the rebar completely, and they use glass fibers, which we are following very closely. We were at the Decathlon, which we go to every time there is one, to see what they're doing for houses that get built off the grid. And the one that we thought was the most intriguing for our region was this one, because it was made of the ductile that we were experimenting with. And it has those qualities of being, if the flood waters rise, it will not allow anything to grow on it, because it is, the pores are really tight, and it is lighter than the regular concrete. So this is a technology and a material to watch. We're in the process of every project that we can. We try to move the ball forward and study it. And I encourage everybody to really figure out how we can improve concrete. We do travel a lot to see how others are living and building with water, because we are obviously on the front lines of that. This was from a trip to the Netherlands. And we hear a lot about the Netherlands. And one of the things that I like about it is, for us, we think that we should be like the Netherlands in that we should be exporting knowledge to the rest of the world for how to build on the coast, but for our climate and for our culture, which is different. And I want to stress that, because sometimes people think, well, why don't we do what the Dutch are doing or the Germans are doing, or what they did in Harvard, or what they're doing in the Northeast. And the reality is that our climate is very different. And so while the lessons are important and the can-do attitude is something that I love, I think we really always have to be based in our own region and our own materiality. Really quickly, this is a couple of new projects that I'm going to show you, two that are in design and one that is in construction. This is an example of what the city is now asking for, which is for us to incorporate freeboard, which is simply lifting the building to have a greater height on the ground floor. We asked for them to change the street trees on this because we wanted to work our landscape architect on this. It's Cadence. We talked about doing the whole project as sort of as an ecosystem, that the entire project, we had an existing building that was a 1950s office that we were keeping and rehabbing, and a new construction. And we added a series of shade trees and rain gardens to capture the water and the runoff from the roofs and put them into cisterns, which we're really excited about. And what that did is, instead of doing the palm trees that they had asked us to do, this will provide shade. And the root system of those trees are designed in such a way that they are also percolating the water and holding the water, in addition to the water that's being run off the roof and held in cisterns. You can see here how that system would work, and it is being done in Miami Beach. It's not new, but the idea people get a little concerned about is, how am I going to design a building that in the future can be lifted? And this is one way, right, where we design a beautiful green edge, and then in the future, when the street gets raised, you have enough height in that first floor for the building to adapt. And so we adaptively reuse and recycle the building next to us, which is really good from a net carbon standpoint. It's adaptive reuse of buildings that can be. But for the new buildings, we plan for the future, and we build in that extra layer of resiliency that can accept that additional height. Here's another one on Wynwood, a different expression because it's a different neighborhood. This is a more of an industrial art focused neighborhood, but it was really about collecting water again on the roof and making that visible to the public and to the residents and to the people that would come and stay at the hotel. And we gave back all of this land that was, the client agreed to make that a park, which we thought was fabulous because there was such a need for green space. And trees are such a partner, and we are so humbled now to when we're talking about green and blue infrastructure, how much of this is a partnership with our landscape architects. You can see the living, there's a farm, a community farm on the roof in the front edge. There's recreational areas for green on the back. And then this one incorporates a paseo, which is a green space with shady trees in an area that really doesn't have any parks. So we thought that was important as well. And finally, this is Grove Central, which is it's in construction right now, and it is getting built. And it's a co-living rental apartment built, transit-oriented design, built right next to the Coconut Grove Metro Rail station, which is really important because obviously the more density I think you build on higher ground, which is where the rail is, the Metro Rail is on higher ground in Florida, it's really important that we build whatever density we're going to build next to transit to get people out of their cars, to protect people because they're going to be on higher ground, and to have equity in different kinds of apartments and sizes and price points to bring people to their jobs and without having to use the car. So from a net carbon standpoint, really getting people off of their cars and the dependency that we have is very important in Miami. And then this shows you just some of the components. We have the residential, the co-living, the solar. We use the rooftop for social as well, but you can see that this roof is producing energy. And we were working with FPNL on this to make it an urban microgrid. Right now it's planned for that. I think that's going to be a phase 2, but what we learned is that every roof can be planned for with very minimal cost for uplift. The conduit can be laid and the battery rooms can be placed so that it can be future-proofed. So when the whatever political and cost arrangements become more, conducive to adding that, it's ready for it. If you try to add it after the fact, the cost is exponentially higher. So every architect and every builder really should be thinking about the future. Even if you can't afford to do it in the first phase, plan for it in your second phase. And this is next to the underlying park, which is a linear park that runs through it. So now we have transit, we have bikes, we have walking, we have retail, and we have people living right up against the station, which for us is really important in a resilient future where you bring everything together. And the idea of having the solar really was, if you have shopping and all the essential goods and services there, pharmacies, banks, then if the grid can support it, the idea was that if power goes out, you have an urban microgrid. It can be an island until of resiliency until the power comes back. And we believe that kind of resilient hub, community resilient hub, is really important in the future, and we are strong proponents of that. And I'll leave you with just some of the images of things that we've done with others. We are very humbled to work with some of the best landscape architects. This is Curtis and Rogers, who's doing the resiliency project with Van Allen and City of Miami on the river, and we're a part of that. And we're learning from them and from the marine biologists and from everyone we work with how to design for water and how to design. This is the image on the left is on the bottom is recycling an old building and turning it into housing, and the image on the upper left is a new housing project in which we incorporate water parks. So we're always proposing that added layer of resiliency in all of our projects. We don't believe that we can be designing the future of this region without it. And since we do care so much about this region and we want it to thrive and into the future, we do think that architects have a very important role to play in that. Thank you very much.
Well, thank you, Jackie, for that. And actually, we've had some questions coming in. Thank you very much. Remember to post your questions on the chat box. And I want to thank, first and foremost, all of the panelists. I've seen your videos now 3 times, and it was actually far more informative the more I would listen. And one of the things that specifically us here at Perkins and Will are always dealing with, and it's been probably the last 20 years, is this idea that has to do with becoming resilient or sustainable, or having this idea of reinforcing best practices, if you will, on this new normal. There's this issue of cost. And there was a couple of questions that came about affordability, but also that if we followed beyond code, if we go beyond code, this represents a premium, and it represents lack of affordability in the kind of projects that we have to do. So Esteban also talked about this building code is enough. And so if today we're dealing with affordability questions from some of our clients regarding putting forth code required, it was interesting to see, and I would say, Jose, you mentioned it, that Puerto Rico is already revising the code to a higher wind threshold, which we haven't done here in Miami yet, and this is extremely important to kind of discuss. But that would also increase affordability, right? Or increase sort of how we're building. So anybody that wants to talk about this, either Jackie or Ricardo or even Laurie, because of affordable housing, which you guys talked about so importantly. I mean, this is the heart, right? The beating heart of our communities is housing and making those resilient. And if we're seeing codes now becoming a lot more, or they should be becoming a lot more robust, what does that mean?
Yeah, I think the question is the code enough? The answer is no. I think the wind definitely is being, as I mentioned, adjusted as we go, but we still aren't seeing enough provisions for increased heat and water. I think where it's baby steps. First, they do it as incentives, like with LEED, when they rolled it out, they started it as sort of, a sticker for good behavior, a rating system, incentives, but eventually it does have to find its way into the code. And I would argue sooner than later, because the more projects that get built that are not future-proofed or ready, the more fighting there will be later to do important infrastructure things like lifting roads and so on. And the cost of that and the public benefit of that needs to be examined carefully, because I believe every time public dollars are spent, there should be a public benefit, including some of the affordable housing and the relocation of people that are in vulnerable areas. So I think there needs to be equity at the table when that sort of thing is discussed. But the more, we've seen it with LEED, and you guys know this, when it became widely adopted and the way that people built, the costs go down. And because that's the reality. The more people that have to do it, the cost is shared across the board. If only a few people are doing it and it's voluntary, we just won't see the widespread adoption that we need to see. That's my opinion. I don't think anyone's going to sign up to do it voluntarily. It just as if, again, using the Hurricane Andrew example and the wind code example, had we made that voluntary, we would be a far less resilient city as we speak right now in terms of wind. Some things should be the code. And I think when it comes to the resiliency of a city or the safety of a city, then we're talking code.
And I don't know whether Laurie or Ricardo or Yanel, if you wanted to comment on that, because I think it also has to do with, again, how are we bringing the best of the solutions to affordable housing, for example, and communities?
I would say a couple of things. One is, can you guys hear me okay?
Yes.
Yeah. I really believe, there's a massive affordable housing crisis across the country, and specifically in Miami. I mean, this is why the Keep Safe Miami effort has been brought to life and is supported now by Miami, Miami Beach, Miami-Dade. The lack of affordable housing is increasing pressures on the economy. There's not enough workforce. People's lives are being spent in highways and traffic. And, we have kids, we have families, we have people that depend on these individuals. If they're driving 2 hours each way to get to a job, that's not sustainable for anyone. And we also know that resiliency is about preserving affordable housing. It's preserving this housing that, frankly, if it's destroyed, if it's in a floodplain, it's very likely it won't get rebuilt. So 2 things are happening in Florida, which are interesting. Number one, we've got a lot more funding now being put out into the communities for affordable housing, coming right from the federal, the White House down. So we have to pay attention to those opportunities. There has to be accessible dollars for communities to build their housing. We've got to have developers that have the resources to develop resilient housing. It has to be woven into the code, the considerations of funding. It's not just code, it's got to be in the funding piece as well, and the planning, and there has to be stipulation. I don't believe that people are going to voluntarily leave their communities because of climate change. I think that what will happen is there will be massive breach in a community. There will be massive event that happens and forces people out without much control or forewarning. People are going to stay in their homes because that's what they know. And, frankly, there's not a lot of places to go to. If you're a single parent with a Section 8 voucher, where are you going to go? So we have to be focusing not just on the receiving, on the communities that are at threat, but on receiving communities. And that conversation needs to be part of this, and it isn't as much as it should be.
That's actually a great great comment, because I mean resiliency and sustainability and protecting our communities is actually a synergistic event. I mean, this is not just about building it successfully, but how are we supporting and its own ecosystem in a way. I think one of the things that a question that was also asked was in terms of what are the I would say models that we're using to sort of inform, and Ricardo and you, Laurie, talked about location being something really important. And like you were saying, there's, there's going to be a shift in how we're going to see urban development moving forward. And I have to say that, I mean, I was in Puerto Rico when Hurricane Hugo hit, and I remember specifically how resilient the city was because it hit the metropolitan area. So it wasn't hitting sort of the lower income communities, but it was fairly resilient. The code was very responsive to some extent at that point. I mean, we had some damage, but nothing like the Andrew sort of destruction of Miami. And so there were two kind of tales of two cities in a way, where there's a response in Miami that led to a new code, that led to a series of best practices, that led to sort of looking at housing in a way, right? Not just low income, but in general, our communities. However, in Puerto Rico, it seems, and I give this to Yanel maybe, and to the team of presentation two, it's amazing to see, and it was very, very good to hear that the code has sort of again gone up into the 180s, which is really what we need to start looking at, and 200-mile-an-hour wind sustains as well. But in Puerto Rico, different from Miami, the code was revised. Miami sort of started looking, or South Florida started looking at the intensity of extreme events. And in Puerto Rico, it seemed that since Hurricane Hugo 30 some years ago, I mean, it went into a decline of infrastructure. And Yanel, you mentioned informal design, which is actually a very important thing that also speaks to what Laurie was speaking and what Ricardo were speaking, which is that in Puerto Rico, the application of the code, or the application of sort of best practices, hasn't reached communities. And now we're dealing over there. You guys were dealing with informal design, right? Which is people building in areas they shouldn't be building, not following the code, not building successfully, and actually not even being, I would say, monitored, right, by entities. So how are you dealing? What is the next level of that? I mean, the code can do can be better, but how are you now in Puerto Rico? I mean, how are you guys in resiliency and this team, not just building to lead by example, with these shelters and saying this is how we need to start thinking of building, but how will this trickle to communities, to housing, and again, it could be Laurie, Ricardo, or Yanel.
I'm going to get it started and then pass it on to Jose, because I think from the perspective of the code and what voluntariado saw, not only, well, recently after the earthquake, he can really get into that. I was had the privilege to work with Laurie and Ricardo on this resilient housing guide. And this is a discussion we had. Is this guide only for professionals, or is this guide for the general public? And we decided we needed to walk that line in between, because the reality is it could be a tool to talk to community leaders, to talk to, everyone in the community and say, this is the reason why your house needs to be resilient. These are the components, and this is why you need a professional. I think if you live through these two hurricanes and you live through the recent earthquake, I think you don't have to work too hard to convince people that they need to seek a professional, but they don't know how. They don't have the resources. And that's how this kind of constellation of nonprofit organizations comes in and kind of, okay, I have this case, can you come in here and help? So I will say in general, people are very receptive to that. And I will let Jose take on the question regarding the code, because I mean, this is what you saw day one on the ground.
Hi, everyone. Again, my name is José Sanchez. I am a senior engineer at Tipping Structural Engineers and a co-founder of the Voluntariados of Engineers. Our group of voluntariado, we deployed within a week after the earthquake, and we went to Puerto Rico to the municipalities affected in the south of the island. We implemented the ATC-20, which is a procedure that FEMA implements right after an earthquake to evaluate if the houses are okay or not for continuing living on them. And we went to the municipality of Gúanica, Yauco, San Sebastián, and then we continue up to this date evaluating homes. So we have seen a wide range of houses across the island and how the informal houses actually are all over the place and in different categories. And the big difference, Pat, going back to like the difference between Florida with Hurricane Andrew and how best practices were implemented, I will say that the main thing is the socio-economical differences between Florida and Puerto Rico. There is a different level of economic level. So people on Puerto Rico don't have the resources to implement best practices, and a lot of times they construct the houses by themselves, and unfortunately they do it with the best intention and trying to do their best, but unless these guidelines that now are being developed, like Laurie mentioned, these people don't have access to them. They will continue doing the same. And I will expand in one example actually of houses that I've been seeing now, results of, for example, concrete compression test. Since we are getting into like the phases of like reconstructing homes, I'm seeing results of like a strength of concrete that doesn't meet code. For example, the code requires a minimum of 4,000 PSI to make sure that the structural element is good. People a lot of times construct the columns themselves, and we don't even meet minimum. So it's a big issue on the island, and I hope our organizations can help.
Yeah, thank you, Jose. And actually, I want to pivot a bit to Joel and Esber. There was a question to you guys regarding sort of this 3D printing and materiality, and actually one of the questions was, how do we see technology informing what you guys were doing? But are any of these prototypes you're thinking being built and this affordability again, or this ability to kind of tap into the new technology, and how is that going to help coastal cities, really? Because your research was really sort of primarily understanding the coastal city condition.
Yeah, thanks for asking. I was actually just starting to type up an answer that was in the Q&A as well about this question about what the most effective solutions are, and I think that I can probably tie my answers of those various questions together to some degree, because the point that I was going to make about the question in the Q&A, which asked about how some straightforward best practices might be universally applicable, actually, I think tends to undersell the complexity of all of the kinds of inputs that are involved, right? And so the truth is that even if there is a great solution for a given set of stakeholders in a specific context, as soon as the context changes or the stakeholders change, actually, you need to kind of reassess those values. And that's the point of the design guide that we have. And so the way that speaks to economic questions is that obviously certain, contexts can afford, different kinds of coastal protections. And certain areas and contexts also might be more willing to admit the need for eventual retreat. And so then what you have to put there in the context of, coastal protections has a lot to do with how long you intend to be there, right? And so sort of thinking in the kind of the various timeframes that matter for occupation has an effect also on these questions of economics. Now, if we are a little bit more reductive and we say, okay, it's not just a question of sort of the many kinds of criteria and the complex questions, but we try to answer it a little bit more simply, then yes, 3D printing is obviously going to be something that promises to improve a lot, both in terms of engineering performance and cost. for a lot of these things, right? I mean, we already see 3D printing, concrete 3D printing happening in sort of single family home scale. The applications there are proving that it's very feasible, that you can do these things in situ, that you can be materially very efficient, right? Because rather than, I mean, the benefit of 3D printing as an idea is that you can place material where it needs to be, right? And so you can allocate material use very precisely, as opposed to all the kind of redundant material use, which is normally necessary in engineered structures, right? And so yes, I mean, I think at least a couple of other characters already referred to concrete as having a huge carbon cost anyway. I know Jacqueline brought that up as well. And yes, we can kind of admit that, but at the same time say that there are both incremental and maybe even revolutionary scale changes available once 3D printing becomes the norm.
And
so,
I just want to, Joel, make sure that we only have 3 minutes left, actually 2 minutes left, or 1 minute left. And I just wanted to make sure that if there were any closing comments, I want to say, I think that this is very interesting that we had sort of a Puerto Rico case study and how extreme events have sort of propelled a lot of these decisions. There were some great questions about what are the other factors that have sort of been challenges to not only the community centers and shelter, but also to the stay safe conditions. There's a lot of what Miami is doing, and Jackie, your firm is doing in terms of propelling some of the ideas into the built environment, and Joel, what you're doing to protect those built environments in sort of surveying sort of these protected barriers, if you will. So I think I want to, sort of close just thanking everyone. And if there are any questions, please be free to either post them on the website or on the chat rooms. We will make them available to our speakers, and they will certainly be able to answer. This has been a privilege. Thank you very much to everyone.